Hi, I'm Grace Ann Baker, Product Manager for Persistent Disk. And before we start off, just want to thank you all for first coming to Next. I know you've taken a lot of time to come here for 3 days, and most importantly, thank you for coming to hear about Persistent Disk.
And I'm Anton Sukhanov. I'm part of Persistent Disk engineering team. And we also have several other engineers from Persistent Disk here who will help to answer questions.
Okay. So just a brief summary. We'll talk about simplicity, performance, snapshots, talk a bit about Persistent Disk and GKE, and some recommended sessions if you wanted to learn a bit more about Persistent Disk or how it's used as a product on GCP, and then open up for questions. Generally speaking, if you have a question, there's a microphone in the middle of the room. Try to keep your questions to the end of the session. However, if there's something that's just not resonating or just doesn't connect, feel free to just raise your hand and we'll try to get to you. The session is being recorded, so please, part of the hygiene on using the microphone is just so that for later use, they'll be able to capture what the question was. And with that, I'll begin. So on GCP, we actually have 3 storage offerings. Or before I go into this, how many of you are GCP users today? Persistent disk users? So that's about, I'd say about 60% of the room. And GCS, object store? Anyone in the room using GCS? OK, so that's goodness. You'll have a fair sense of what the product is. And in which case, if you would like deeper information, ask questions. We're also going to be around later on, so if you'd like to just give me your name and we could arrange to talk offline after. So on GCP right now, we have 3 storage options. We have our object storage, and we actually have 2 storage offerings that are both for block storage, available for Compute Engine, our VMware-based product. GCS is our object storage. It's geo-redundant, primarily used for live and archival data, a lot of more streaming work cases. For block storage, or for GCE, we have what's called local SSD. And the way to think about local SSD is that it is running in the same machine as your VM or as the instance. It tends to be used for workloads that require very ultra-high performance. However, the one caveat is that it's ephemeral. So if anything should happen to that VM, your data is also gone. So the life of your data exists just in the construct of that instance. Persistent disk, on the other hand, which is the other storage offering, is the disk available for any VM that you're using as part of GCE. It is highly durable, which means that the disk is a standalone entity. If the VM goes away or comes back, or you would like to use that disk of different VMs, you can do that. Fairly high performance, and so this is a product that's targeted at enterprise applications. Any virtualized enterprise applications requiring virtual block storage is where you would use persistent disk. So when you're thinking of performance, that's the level of performance we're talking about with persistent disk. And just as a caveat, this is the product we're going to talk about today. If you're interested, there are lots of sessions focused specifically on GCS. Local SSD is being addressed in the context of Compute Engine, and so if you're interested in learning more, I suggest some of the Compute Engine sessions. And today we're talking about persistent disk, which you'll hear me refer to as PD. I do have some sessions listed at the back of the presentation, so if anyone's interested in some of those other sessions, it's in the presentation. So starting with persistent disk and 2 SKUs, I think one of the key things about GCP in general, and specific to GCE and persistent disk, is we really try to keep it simple for our customers. We don't have a large set of options available for customers, and the idea there is that rather than customers having to really think hard about what are their workloads, what are their use cases, and then try to map it to different SKUs offering, we really try to keep it simple as to 2 offerings. And you'll see a lot of things are just bundled as part of the base offering, or these two SKUs will stretch and fit different workloads. So starting out with key characteristics, PD standard is really what you would see being used for more of our general purpose workloads. Thing about there, it's good enough performance. And when I say good enough, people are always like, Raysen, what is good enough? Good enough turns out to be good enough for the bulk or the large swath of enterprise applications that really don't need ultra-high performance that you would see or that's available with your flash drives. And when I'm talking performance there, I'm talking both latency and also IOPS. And so if you've got your enterprise database that really need high throughput, high bandwidth, high latency, then definitely PD SSD is most likely your product. The other thing there is you tend to be less price sensitive for those types of applications. Those are the applications that you would run on PD SSD. For most of your other applications, they do fairly well on PD standard. And this is just a typical, and I know that in the enterprise it really isn't any typical applications. And I know that people will say, well, I show enterprise apps as PD SSD. Truthfully, they run in either of these columns. Other key points is just to give in a sense of how do we differentiate these two? What are the key characteristics between PD standard and PD SSD? You can see IOPS per gig. And here you're seeing a meaningful difference between the two offerings. For PD SSD, you've got 30 IOPS per gig, whereas for standard, it's just 0.75 for read and 1.5 for write. For things, if you look at your max IOPS, you're going to see for PD standard, for reads, it's 3K, for writes, 15K. PD SSD, on the other hand, it's 40K read IOPS and 30K for write IOPS. And I'll just pause for a minute here and comment that that is actually something new. Today at Next, one of the things we're announcing is the higher IOPS availability for PD SSD. So if anyone, that is available today. If for many of you who said that you are using PD, if you're using persistent disk SSD, you're getting that performance level today, or you should be, and if you're not, please let us know. And last point on this, because I know a lot of people are probably wondering, so what's the big difference according to, that goes beyond the characteristics of the drives themselves. You could see there's a significant price difference between these two offerings. Okay, so when you just talking a bit more about what is persistent disk and the key features. So I mentioned earlier that it's persistent, and that's really just comes back to this construct of the life of your disk is not tied to the life of your instance. And so, however, most of the time to use your persistent disk, someone creates a VM on Compute Engine, and with that, you're also going to create a disk to go with it. Anything should happen to that disk, anything should happen to the connectivity to the disk lives on. You should then decide that you're going to have another application that needs access to that same data, just create that new instance and connect it to your disk, and you're up and running. We have this idea of how many disks that you can attach to a VM, and we hear this fairly often. And so the number of disks that you can attach to any given instance is 16 drives or 16 disks. Up to, and you can have both read-write and read-only disks. At any given time, you can only have one read-write disk attached to a VM, but the number of read-only will vary. And that's really up for you to decide. And here you can also, another feature of the product is you can have, for those read-only disks, you can have those being read to from multiple VMs. Also, once again, that's up for you to decide for your different environment. And on the subject of availability, PD is a zonal service. And what that means is that one of the only restrictions around persistent disk is that it needs to live, or it does live, in the same zone as your VM instance. They're highly available. And under the covers, one of the things we do with persistent disk to drive the high availability is for every write, there's actually 3 replicas written. Customers are, of course, only charged for one one of those copies. However, the way that we deliver greater availability to customers is this idea of the multiple writes being done onto the covers. And this here is just intended to show that this whole construct of if you have multiple PDs and you happen to have those instances in different zones, the disks that attach to those instances will all also exist in those different zones. Talk a bit about capacity and the actual numbers for the systems. So the maximum PD size right now is 64 terabytes. One of the things we're very interested in is if anyone has the need, or how big is the need for that number to increase. It's one of those things that we've been working on doing, but priorities change, and so I'd love to get a signal as to how important that is. For most customers, we're seeing that 20 to 30 terabytes is good enough. We do have some larger, but that's something that would be interested to know about. Coming back to this, how many disk size to a VM, if you recall earlier I mentioned that you can actually have multiple disks attached to a VM. One of the constraints, even though you can go up to 16 disks, the sum of those 16 disks cannot exceed 64 terabytes. So you can't have like 16 64 terabyte disks attached to a VM. And I think one of the key things here is this whole construct of do you need to stripe or not? And this is one of the things that's key differentiator for us, is this idea that you can go up to have this very large drive and not have to stripe them. So there's a whole level of management complexity or management overhead that you don't even need to think about as you scale your data set to these larger numbers. And then lastly, I think one of the other things that the team stresses with me is this whole construct of being able to hot grow your disk. So often, sometimes you're not sure what size disk to get, and so you start small, and as your needs grow, you can readily just grow your disk size without having to stop and restart or do anything on the VM. And so once again, just giving you a lot of flexibility without any downtime in your environment. On the subject of encryption and security, and this is one of those features where, coming back to the point of trying to keep the product simple, trying not to have a whole bunch of bells and whistles that people have to think about for their different data sets in their environment. With persistent disk and on the platform as a whole, all of your data is encrypted, and it's always on. It's one of the core features, and we support both. By default, it's Google-generated keys. But for instances or customers where they have their own keys, we also support that. So it's fully integrated with our cloud KMS system. And I think one of the other things on the subject of security is because Google Cloud runs entirely in the Google network, your data never leaves the Google network. So there's no concern about being on the public internet. And so there's this idea of, well, what about data in flight? And so the question is, well, it's never leaving the Google network, and it's encrypted whilst it's on the network. So it's just a different way of thinking of the product and of security and the data on the network. Okay.
Performance we take very seriously in persistent disk, and today we are proud to announce substantial performance increases for our PD SSD product. For IOPS, we are increasing from 25,000 to 30,000 IOPS on writes and 40,000 read IOPS. And throughput increases are even more substantial. We go from 240 megabytes per second to 400 megabytes per second writes and 800 megabytes per second reads. Also, today we are announcing full duplex on SSD throughput. What does it mean? It means that you can achieve 400 megabyte per second reads and 800 megabyte per second writes at the same time. This is not true for IOPS. So IOPS, you still can do either one or another limits. But for throughput, duplex throughput is important for many enterprise applications, and we were asked many times to provide this feature. So it's really exciting today. Now, I want to mention that when we talk about IOPS, it's important to understand that persistent disk is a networking disk, which is really cool for availability because you can take one persistent disk, as Grayson mentioned, attach it to any VM. And you can shut down the VM, you can keep your disk, then attach them later. It also brings high availability of the persistent disks. But it comes with some cost, and the cost is a little bit of extra latency. Our latencies are competitive on the market, but we need to understand that to get to the high IOPS limit, your workloads should maintain certain queue depths, especially for these ultra-high IOPS loads. The new increases, they come for large VMs. So for VMs up to 15 cores, we keep the old limits. But from 16 cores and up, the limits are increased, and the maximum limits can be achieved on 32 and higher VMs, 32 cores and higher. Persistent disk standard, at this point, characteristics are not changed, but I just would like to mention again that we offer very competitive price for performance ratio for PD standard disk, and currently it can go to 15,000 write IOPS and up to 3,000 read IOPS. And throughput is 120 megabytes per second on writes and 180 on reads. So a little bit about how we approach performance. For us, the simplicity is very important in approach to both queues and performance. We want to offer consistent performance. So you pay certain price for size, you get IOPS, you get throughput with this size, and you get consistent performance in every zone where persistent disk is offered. You don't need to bother with striping, as Grayson mentioned, and in persistent disk, to get the best performance, you can just attach one large disk if it suits your workloads. Or another choice is you can attach many small disks and you can attach them to the same VM and you get the same performance as large disks. We know that some other solutions, they require striping, which is very is not very good solution for the customers. So we are happy that we offer simplicity here. The disk size, we want you to have the disk size chosen for performance and for space. And then if you need to get more performance, we have online resize for you. And by the way, performance is something that we take very seriously in PD, and we are always looking for the feedback. I'm sure we have customers in the room, and we would like to learn more about your scenarios. If you think we need to deliver more IOPS, more throughput, if you think our model is too simple, we would like to talk.
Okay. Snapshots. And so one of the big requirements we hear from enterprises or most of our customers is, so what happens in the event of a failure? Or what if I want multiple copies of my data? How do you do that? What do you have available for us? First thing we have is snapshots. And think of this is very similar to what most of you are familiar with, an on-prem storage array. Snapshots exist independent of the source. And what I mean by that is that snapshots will exist in a different zone and region than the actual primary data. And let me just pause for a second about the construct of a zone, a region. GCP is actually set up it's broken down into, you have your geo areas. Nested inside of the geo areas, you have your different regions, and then inside of the region, you have your zone. Similar to other cloud products, I don't think anyone has really filed a patent on how they structure that overall structure, tiering of the network. For snapshots, as I mentioned earlier, for persistent disk, you have your VM, and the data associated with the VM is sitting in a zone. And here I talk about zone A just to make it simple. And zone A and the VM and the disk are all sitting in region A. What it's trying to show here is that you have a snapshot, and that snapshot is actually living elsewhere in a different region than your primary data. Key thing here, and the key ask that we get from customers is, well, what happens if zone A disappears? And we've all been around for a while. A zone isn't likely to just poof and disappear, but what if there's a failure in that zone? What if I lose that data? Will I also lose the copy of that data? And the answer is no. Under most circumstances, you shouldn't, because it's quite unlikely that you're going to have a failure that'll affect both region A and a region somewhere else in the country. One of the key things about snapshots is today, right now, snapshots is totally, it's a feature that's available as part of persistent disk, but the control is totally within the customer. So the frequency, well, first and foremost, if you'd like to snapshot your data, that's something that we leave up to customers, and not all customers choose to snapshot their data. So let me just start with that. And then the next thing is the frequency of snapshotting is also something that's up to customers. The technology right now is not intended to be used as an alternative to synchronous replication. So, the idea of snapshotting every minute or every couple of minutes, system wasn't built for that. And what will happen, quite frankly, is that you'll see that your snapshots take a very long time to complete. However, but what we do see, and what's more, where the system's more optimized for is snapshots daily, snapshots every couple of hours, during a day. Those are the typical use cases that we see for snapshots. And they're primarily what people are using is for us to have a backup copy or have a second or third copy of a given data set. Another big question we often get about is, where are my snapshots stored? And I know there's some people that says, why does it matter? And I know for customers that the big thing here is coming back to this question of, is it in the event of a failure, does it have the same risk as the active data? But some customers just want to know that regionally, there's some geopolitical issues at play for some customers. And so the answer here is just it's stored in GCS. Right now, we do not make any of the GCS APIs available for the objects, and so the only access that customers have to these snapshots is via persistent disk. But if there are customers that are interested in that level of functionality, please ping me after, because I would love to better understand that use case. And one of the key things about snapshots and how they're used is this idea of you can restore a snapshot anywhere. And so quite often what we see customers doing, and just earlier today we had a customer who's using persistent disk and in region A, and they now would like to fire up a different database instance using the same data set in, they're in the Midwest, and they have an office in the West Coast, and they'd like to use that same data set. And so one of the great use cases for snapshots is you take a snapshot of the data set, you create an instance in that second zone, create your persistent disk in that second zone, and at the same time, then copy the data from your snapshot over to that second location. And that's one way of getting access to that same data set in multiple locations. We have the other use case here is a temporal one, where you have persistent disk, and you've got all your data, you're using it this week, and it's data that you only use once a month. Rather than pay for the disk and keep it live all the time, they'll take a snapshot of the data, park it, and a month from now they'll create another instance, remount the snapshot, and use the data again. So it's just another way of having access to your data in a more temporal fashion than having it mounted all the time. One of the key things about snapshots is this idea that it's cost efficient. This becomes relevant because customers are very cognizant to the side of these, you're keeping copies of your data. How much data are you keeping? And a lot of it is repetitive data. And so do you really need to keep many, many copies of the same data? So our snapshots are cost efficient in the sense of we do both full and incremental snapshots. Generally, the first time that you take a snapshot, we will do a snapshot of the entire disk, and that's considered a full snapshot. For future snapshots, we will take differentials, and so only the blocks that have changed will be kept on a long-term basis. There are times in the future, so it's not just one full and incremental indefinitely. We do periodically do full also. And so but the key point is, it's not, if you choose to snapshot on a daily basis, we're not doing full snapshots every day.
Some of the best practices for performance at snapshots. We think it's a good practice to separate data logs and the boot disks. It makes it easier for you to manage backups and restores. Don't worry if your boot disk is small. Some customers, they tell us they create big disks for boot and for data because bigger disks have better performance. We optimize even small disks for good boot performance. So the striping we mentioned, sizing for space and performance, resize, the queue depth. We also recommend if it is possible to adjust your workload to have a more localized access. You will get somewhat better performance from persistent disk. For snapshots, you can take snapshots without stopping your workload. I think it's a really cool feature, and it actually has no effect on the workload. So you can keep writing to the disk, take snapshot at the same time. As a matter of fact, take multiple snapshots. But you have to understand that your application should be able to restore data at the point where you take snapshot. Most databases and file systems, they can, but it's something to be aware of. Test restore operations. As we like to say, good engineers backup and awesome engineers restore. So backup your data, restore periodically in different zones to make sure everything works. About the schedule of snapshot schedule, first of all, making snapshots every second, maybe it's possible, but it's not something we recommend. Half an hour, every 1 hour is acceptable, maybe every day. We have customers who have custom scripts for their needs. Try not to schedule snapshots of business hours or weekdays. And important for snapshots, because we do snapshots incrementally, your next snapshots will be fast. It can be more snapshots actually done within minutes. You can make it even faster and reduce cost if you use Stream, if it's not enabled, because we do not snapshot data which is not on the disk.
And then GKE, this is Kubernetes or container engine. And I think the key point here, I am not a GKE expert, so let me start there. The key point here is that for Kubernetes actually uses, or GKE actually uses persistent disk as the storage for the containers. So when you create a container Kubernetes cluster, the storage or persistent volumes that are made available to the cluster are all persistent disks running under the cover. Is working with the GKE team. They wanted me to mention this here, and if there's any questions or interest in this, there, as I mentioned earlier, there's other sessions, or I think there's folks here that can answer any of those questions.